Hello, let f of x equals x squared, g of x equals square root of x minus 3. Find f of g of x, g of f of x, f of x, g of x, and their domain. Now notice that these are not, this is f of g of x, it's a function composition, it's not f times g. There's a major difference in there. So let's start with f of g of x. Okay. Notice that f of x is only x squared, and there is no restriction on the domain whatsoever. So let me keep a record of the domain of f of x. We said that f of x is x to the second, and so the domain is all real numbers. You can say all real numbers like that, or you could say from negative infinity to positive infinity. How about g of x? Notice that g of x equals square root of x minus 3. And in here, x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to positive 3. Now, f of g of x, f of g of x equals, notice that the inner function is g, so I'm going to put g inside of f. So once again, g is my inner function and f is my outer function. So we are going this way. So I'm going to have square root of x minus 3 quantity square. Well, that equals just x minus 3. Okay. So x minus 3 itself doesn't have any restriction for the domain, but I must be mindful of the inner function, in this case, g. So remember that the g had restriction, that x had to be greater than or equal to 3. So the domain of f of g of x is, okay, from x has to be greater than or equal to 3, so and 3 is included. So I have from 3 to infinity. So once again, notice that starting 3, if I put the 3 inside of g, square root of 3 minus 3 is 3 minus 3 is 0, square root of 0 is 0, that's meaningful. And here for the f of g of x, there was no restriction. Okay, let's move to g of f of x. G of f of x. Notice that this time f is the inner function. I'm going to take f and put it inside of g. So that equals square root of, instead of x, now I put x squared, and I have minus 3. Okay. Now in this case, I know that x minus 3, x squared minus 3, x squared minus 3, okay, for g of f of x has to be greater than or equal to 0. That means that x squared has to be greater than or equal to 3. And that means that x has to be, so if I want to find my critical point, if I say x squared minus 3 equals 0. So I can factor this, or I can say x squared equals to 3 and x equals plus and minus square root of 3. So plus and minus square root of 3 are my critical points. I'm going to test points. So here is negative root 3, here is positive root 3. I'm going to test numbers in between. To the left of negative 3, let's say if I pick negative 2, negative 2 squared is 4, minus 3 is 1, 1 is greater than or equal to 0. So to the left of negative 3, I get solutions. I'm going to put T for true. A natural number to test between negative root 3 and positive root 3 is 0. If I plug in 0 in here, I get 0 squared, which is 0 minus 3. So minus 3 is not greater than or equal to 0. And so I'm going to put false in here. And if I pick a number to the right of 3, let's say 4, 5, to the right of square root of 3, let's say 5. 5 squared is 25, minus 3 is 22. That is greater than or equal to 0. So notice that, so the domain for g of f of x, I have to mind this part. And I have to also keep in mind, what was the domain of the inner function f? Well, f of x, we said that it was x squared, so there is no restriction. The domain of x squared is all real numbers. So the domain of g of f of x, now I have negative infinity to 3 together with from, oh, this was, sorry, square root of 3. Together with square root of 3 all the way to infinity. Let's go to the next page, and this time let's find what is f of x. So I'm going to take f and put it inside of itself. So we know that we were told that f of x equals simply x squared. There is no restriction. So f of x equals x squared, which is f, put it inside of itself. So now I have x to the power of 4, okay? And the domain is from negative infinity to positive infinity. There was no restriction. Let's go to g of x. And we know that g of x, we were told, equals to x minus 3. So there is a restriction. So first of all, for g of x, I'm going to pick g and put it inside of itself. So I'm going to have square root of x minus 3, and here's my minus 3 in here. So take g and put it inside of itself. So here we know for the restriction, we know that this thing inside of the big square root has to be greater than or equal to 0. So if I say that square root of x minus 3 has to be greater than or equal to 0. So I know that square root of x minus 3 has to be greater than or equal to 3. So to find my critical point, I'm going to just set that equal, use equal sign, equal 3. If I square both sides of this equation, I get x minus 3 equals 9, and add 3 to both sides, I get x equals to 12. So my critical point is at 12. If I pick a number to the left of 12, let's say 0, and I plug that in here, that's not going to work because I'm going to get square root of negative 3. So this to the left of 12, I don't have any any solution. How about 12 itself? The 12 itself, if I plug in 12 itself, I get square root of 12 minus 3, which is square root of 9. Square root of 9 is 3. 3 minus 3 is 0. And square root of 0 is 0. So that is actually, I'm going to put small t because this is part of the domain. And to the right of 12, any number I pick, let's say 20, 30, 50, 13, it's going to give me a positive number. So this is true. Okay. So notice that for g of x itself, we said that x has to be greater than or equal to positive 3. But for g of x from here, I know that the domain of -3 is somewhere in here. So the domain for g of x is going to be from 12 to infinity. Okay, thanks.